Over the past 10 years, the world has seen a substantial change in the food market. On one side, we have consumers who are becoming more and more aware of health and sustainability issues. On the other side, in 2050, we need to feed approximately 9.8 billion people. While thinking, will we have enough food for them? We should also wonder, will we be able to provide all the essential nutrients to them? And by essential nutrients, we mean all those nutrients which our body, for some reason, cannot produce and need to be introduced with the diet. Hello everyone, my name is Mara Lauriola, and in this video I'm gonna talk about my research project conducted at the Reed Institute, Mass University in New Zealand. Our aim has been that of quantifying the absorption of essential amino acids in the human colon. So we can imagine amino acids as components of a bike. One amino acid corresponds to the frame, one to the front wheel, one to the back one to the saddle, and so on. So what happens when we don't have all these parts at the same time? And what happens if we have all these components but not in the right size? We cannot build any bike with a tricycle wheel. And clearly we cannot build any bike when one piece is missing. All the other components become suddenly useless, right? The same happens within our body. 15% of our body weight is constituted by proteins, and proteins are made of amino acids. When one essential amino acid is missing in a diet, the other amino acids provided cannot be utilized by our body to build up the proteins it needs, and the liver convert them into urea. Urea will then be excreted in the urine. This is why urea to creatinine ratio could represent a good urinary biomarker to detect if there is absorption of all the essential amino acids or not. Absorption of amino acids is thought to occur only along the small intestine, but not in the colon. On this assumption relies also the definition of protein quality according to the FAO, the Food and Agriculture Organization. Even though that has been reported in animal studies, no previous studies exist for humans. Measuring if there is an actual decrease in urea excretion when an essential amino acid is infused into the colon after administering a meal deficient in that specific amino acid could represent the right method. However, before that, the conditions must be defined. How much the meal must be deficient, when to infuse the amino acid. 12 participants received in two separate occasions 2 test meals, one providing the complete amino acid pattern and the other one 60% lysine deficient. Despite urea to creatinine ratio measured in urinary samples collected at time 2, 4 and 6 hours after the test meals showed no statistical difference between the two test meals, the data has been useful to define a new protocol, which is currently ongoing.